Hello friends, welcome to this new tutorial, and today we are going to make a very exciting project. We are going to make a PWM generator using ladder logic. Okay, so what we'll have to do, when we start a push button, there should be a pulse of 2 seconds. Then this pulse should be off for 3 seconds and again should be off for 2 seconds. This cycle will repeat. So that's how we will make a pulse width modulation generator. Okay, and also this project is very much necessary when you are using a timer. It will improve your concept on the timers. Okay, how we use it, how can we use interlock in the timers. Okay, so let's see in the program how we'll make this pulse width modulation generator. Okay, let's start making the program of pulse width modulation generator. So here what we required input to start the generator, one output which will show that the pulse width generator is working, means it will start for 2 seconds and will off for 3 seconds, and we require two timers, one timer to start the pulse and this other timer to stop the pulse. Okay, so let's see. Suppose okay, yeah, dp x0, this is our input. Okay, we are giving a pulse. After giving a pulse, our output m0 is high. Okay, and we latch this m0 to this. Okay, so what will happen when I press x0? M0 will be high, it will be latched. So after the pulse gone, it will continue to be high. So this LD, this m0 will start a timer t0 k20, means a 2 second time. Okay, so it will all start. As soon as this timer T0 will high, what will it will do? It will stop this output. Okay. Also, we can make a thing here that when M0 will high, okay, LD M0 when it is high, it will make our output Y0 high. Okay. So what happens? We press X0, this M0 will be high, output will be high, and the timer will start. After 2 seconds, this timer will be high. So what I did, I put the inverse of T0. So as T0 will high, this will be off, output will be off. Okay, so this is our first condition. But we also have to restart the generator after 3 seconds. So what will I do? This T0 LD, okay, this T0 will set a bit called M1. Okay, and this M1 will start another timer TM1 T1 K30, which is a 3-second timer. Okay, now what will happen after 3 seconds? Since what has happened, this whole after 2 seconds, this whole cycle will stop. This timer T0 will set this M1. This M1 will start a timer T0. So after 3 seconds, this timer will again give a pulse to M0. So what will happen? LD T1, okay, and here is our command. So T1 will give a command to M0. Again, the cycle will start. Okay, but we record one thing. This M1 is high. Okay, so but one thing is there. This M1 is high. So when timer T1 will high, oh sorry, timer T1 will high, it will do another thing. It will reset our M1. Okay, it will reset our M1 and parallelly it gives a command to this M0. This M0 will again start the generator. Okay, so let's see in run mode how it works. So first of all, we will compile it. Okay, compiling is okay. Now we will go online. Okay, oh, sorry, this is online. Okay, we will go online in run mode, and now let's see. I give this x1 a bus. Y0 is on. After 2 seconds, it is off. Okay, this is the count. After 2 seconds, it is on. We can see this in uh, our output is Y0. Okay, you can see on, off, again on, again on. This is off for 3 seconds and on for 2 seconds. So this is our a pulse width modulation generator. So by using those two timers we can make a pulse width modulation generator. Okay, so look at the program, try to make more programs like this. It will improve your logic, your interlockings. Okay, so try hard, try best, all the best. Okay, meet you in the next video.